Okay, today we're going to convert negative floating point binary numbers into denary or decimal. Before we go through our first example, I want to show you the steps to follow to do this. So first you have to find the 2's complement of the mantissa, translate the exponent to denary, move the point left or right depending on if it's positive or negative, and then translate that number into denary, and always remember to add the negative sign as well, because of course it is a negative binary number you're translating. So with our first example, of course we're going to have a sign bit of 1 which shows a negative number, so that 1 will be our sign bit. We're going to have a mantissa which is going to be 0 1 0 1 1 0 1. That's going to be our mantissa. And we're going to have an exponent of 0 1 0 1. That's going to be our exponent. Right, to find the 2's complement of the mantissa, we need to flip all the digits and then add 1. So it's going to be 0.0, oh, not 0 there. It's going to be 1 0 1 0 0 1 0. Add 1, and that will give us, of course, 0.101001 1. This is our 2's complement of the original number. So we've done step 1. Now I want to look at step 2 to translate the exponent into denary. So this is going to be equal to 5. So we have an exponent of 5 or plus 5, which means we're going to be moving the decimal point 5 places to the right. So that means it will end up like this: 1 2 3 4 5 right here. So let's rewrite this so it's a bit clearer. So it's going to be equal to 0 1 0 1 0 0.11. So let's add our place value holders to work this out. So we got a half, a quarter, 1 2 4 8 16 32. So it'll be 16 plus 4 plus 0.5 plus 0.25, and that will equal to 20.75. And of course you must remember to add the negative number. So that's our final answer there. Okay? Right, let's have a look at the next example. So we have a sign bit of 1. Our mantissa is going to be equal to 0 0 0 1 1 1 1. That's going to be our mantissa. And we're going to have an exponent of 0 1 0 0. That's our exponent. So step 1 is to find the 2's complement of the mantissa. So we'll have 0.11100000. Add 1 to that. That gives us 0.11100001. That's our 2's complement of the original number. Let's now work out the exponent. The exponent is going to be equal to 4, which means we're going to move it 4 places to the right. So we'll end up right there. So if we rewrite that, we'll have 0.1110.001. Let's add our place value holders to work this out. So we'll have an eighth there, a quarter, a half, 1 2 4 8 16. So it'll be 8 plus 4 plus 2 plus 0.125. That will equal to 14.125, and of course let's add the negative sign. There we go. So if you got that right, well done. I've got one more example to talk through. Right, so firstly we're going to have, of course, a sign bit of 1. We're going to have a mantissa That's equal to 0, 0, 1, 0, 0, 0, 0. That's our mantissa. And then we're going to have an exponent of 1, 1, 1, 0. That's going to be our exponent. Okay, right, pause the video here and see if you can work out the answer using the steps we've worked through. Okay, let's talk through how to work out the answer. So of course we'll flip the mantissa to find the 2's complement. We'll add 1 to this. That will give us, okay, 0, and we have a 1 here. That'll be 0, carry the 1 again, add them up, 0, carry the 1 again, add them up, 0, carry the 1, so it'll be 1 there, and then you have 1, 1, 0.0. So this is our 2's complement number of the original number. So let's work out the exponent. Again, we've got a sign bit here now, so we have to find the 2's complement of this number to work out what it is in denary. So we're going to have to flip it again, add 1, that gives us 0, carry the 1, 0, 0, that equals 2, and of course it's a negative number, so we must add the negative sign there. So if it's a negative 2, that means we're moving the decimal point 2 places to the left here, so it'll be 1, 2, which means then we will most likely have a drop off here. These 2 here are going to be removed because we have to maintain the same number of bits. So we should have then 0.001100. So notice that we've lost 2. Oh, missed out a 1 there. We've lost 2 of these zeros here. So now we've got this. So let's add our place value holders. So we should have a half, a quarter, an eighth, a 16th, and a 32nd as well. So let's work this out. So it should be 0.125 plus 0.0625 plus 0.03125, 0.21875, and of course we must add the negative number there as well, and that's our final answer. So well done if you got that right. So today you've learned how to convert negative floating point binary numbers into denary. Well done, and thank you for listening. Any questions you've got, stick them in the comment section below.